Good morning, children. Today we are going to do exercise 2.9 based on properties of definite integrals. Now, what do you mean by definite integral? Whenever I am given some lower number to some upper number and some function like this. So, this we call a definite integral. Instead of 2, let me call a, and instead of 5, let me call b, and the function in general f of x dx. This definite integral, how and all I can use the properties. For example, see, you are starting from your house and you proceed on to school, that is a to b. Evening, you return. You go in the same way, but the direction changes. So, a to b f of x dx, supposing I change it from b to a, the distance covered from school to home or home to school does not change. What changes is the direction. So, morning you go forward means evening you come backwards. So, what alone changes? The symbol. So, remember, in integration, whenever I interchange the lower and upper limits, the sign changes. A very important property. Now, in the given integral, instead of x, if I want, I can change throughout as t or y or z or u or any other variable. So, that is the very first property of definite integral. Wherever x comes, if I need, I can change it as some other variable, either y or z or t or u. So, f of x dx can very well be written as f of t dt. That is the very first property. Number 2 is what we said here. Whenever I interchange the limits, the sign changes. Value doesn't change, only the sign changes. Third property, whenever we are adding two functions or even subtracting, integral of the two together can be split. A to b f of x plus g of x dx can very well be written as integral a to b f of x dx plus integral a to b g of x dx. Similarly with a minus symbol, provided f of x and g of x are continuous functions in the closed interval ab. Now, the next important property is, again we'll go back to your home to school example. Start from your home and you want to reach your school. Now, not necessary you directly come to school. You can go to your friend's place, C, and then C, that is your friend's place, to school. So, A is your home and B is your school, but in between you can stop at your friend's place. So, A to C plus C to B, the same old function. You can remember, I can cancel this upper and lower. Finally, I arrive at A to B. So, remember, starting place and final ending should be the same. Not necessarily one friend. I can have two friends. So, A to C. C is the first friend with whom I am going to the second place. Then D to B also I can write. This is also correct. Like this. Any number of intermediate, will see this C cancel, this D cancel. Starting is A and ending is B. Like this. You can put any number of intermediate values. So that is a property. And remember, your friend's house should not be somewhere else. You cannot change your direction. Your friend's place must be within your school and home limit. Is the idea clear? C is somewhere means you cannot go and take her. On the way, you can meet your friend and pick her and go. So that is the idea. We say when C is between A and B, A to B can be very well written as A to C plus C to B. Again here we say it's a continuous function. Now the last three are the most important properties that we often use in the exercise. What is that? Integral 0 to a f of x dx. Wherever this x is coming, let me put a minus x. Lower limit is 0, upper limit is a. So wherever x comes, let me put a minus x. So wherever x comes, we put a minus x. The integral limits do not change. Dx do not change. Only x becomes a minus x. So remember this idea we often use in problems where and all 0 to 1, 0 to pi by 2 like that are coming in the exercise. Now the next idea is supposing lower limit is a and the upper limit is b. Now what should I do? Again, a to b there is no change, dx there is no change, x alone will become a plus b minus x. So wherever a minus x is coming, now since the limits are different, let me put a plus b minus x. So these are the very important properties that we often use in the exercise problems. So let us remember integral 0 to a f of x dx equals integral 0 to a f of a minus x dx. Similarly, when it is from a to b, wherever x is coming, let me replace a plus b minus x, and dx, the limits, the integral, there is no change. Now the last property that I often use is about odd function and then even function. We have already learned about these things in standard 11. Anyway, let us recall. Suppose my question is x, x cube, x power 5 and so on. Wherever x is coming, if I replace minus x, this will become minus x. Minus x the whole cube is minus x cube. Minus x the whole power 5 is minus x power 5 and so on. So, f of minus x is becoming minus f of x. So, that is called odd function. F of x, wherever x is coming, if I replace by minus x, the sign itself changes. That is called odd function. In trigonometry, only cos and secant are even, all the remaining are odd functions. Mostly you can remember with x, x cube and all. Whenever the power is odd, the function itself is odd. And whenever the power is even, the function itself is even. For example, if I take x square, x power 4, x power 6 like this, wherever x comes, let me replace minus x. Minus x, the whole square, will still become x square. Minus x, the whole power 4, will yield only x power 4. Minus x, the whole power 6, will yield me only x power 6. So notice the difference. When the power is odd, the sign changes. When the power is even, the sign does not change. F of minus x is f of x only. So such functions are called even functions. Now the question is, once you find out whether they are odd or even, supposing I have like this minus a to e, f of x dx. It is somewhat like our number line, let me say. This is minus a, this is 0 and plus a. Odd function means here my answer is plus 40, means here my answer will be minus 40. Whenever it is odd function. So what happens? This and this will get cancel and my answer is 0. So remember the idea. Whenever it is from minus a to plus a and f of x dx is coming and this is an odd function, my answer is 0. Suppose it is even. Now what happens? Here it is plus 40 means here also plus 40 only because it is what function? Even. Odd means sign changes. Even means sign doesn't change. Now it becomes 2 times because 40 plus 40 twice 40. So 2 times 0 to a f of x dx. So in 1 mark problems in objective type questions, we are mostly given odd functions. Once you decide it is odd, you need not even integrate, put the limit, all that, immediately declare the answer to be 0, provided the limits are from minus a to a, minus 2 to 2, minus 3 to 3, minus 4 to 4. Such functions, I say the answer is 0. As we proceed on to the exercise, just check whenever the limits are from minus to plus and the question is say x cube dx. Tell me the answer. This is minus 2 to plus 2. Same number, negative to positive. And the power is odd. The entire function itself is odd. No need to do the problem. Immediately declare it is 0. Just say it is an odd function. By using the property of definite integral, we say it to be 0. So these are the most important cases wherein we apply the properties of definite integrals. Suppose sin x is coming. Now what is the answer? Now what is the answer? Now also sin x dx is given. Now also my answer is 0 because it is odd function. Suppose if it is sin square x, is it odd? Whenever the power is even, the entire function becomes even. So the answer will be 2 times 0 to pi by 2 sin square x dx, and then we'll have to proceed with the usual integration. So we shall start with the exercise now. It is exercise 2.9, question number 1. I equals integral minus pi by 4 to pi by 4 x cube cos cube x dx. What is your answer? It is from negative number to positive number. Same number. So what formula will I use? Minus a to a f of x dx. Tell me whether it is odd or even. Cos by all means even only. Whatever be the power of cos is even. But what about x cube? The power is odd. So odd into even will still be odd only, and so my answer will be 0. So this function you can immediately declare the answer to be 0, explaining the fact f of x is odd, minus a to plus a f of x dx, the integral is 0. Now how am I to say it is odd? I simply say, but it's better that you prove it. F of minus x is equal to, wherever x is coming, let me put minus. So minus x cube cos cube of minus x. Minus the whole cube becomes minus x cube. Cos by all means positive. So I write like this. So f of minus x is becoming minus f of x. See, question is x cube cos cube x, but I get minus x cube cos cube x. So whenever f of minus x is minus f of x, just declare it is odd function and my answer is 0. Those who are unable to follow all this, at least check roughly whether it is odd or even and write the answer. Question number 2. I equals integral minus pi by 2 to pi by 2 sin square theta d theta. Here again the limits are from minus to plus. Same number, minus a to plus a format. Check whether it is odd or even. See, it is sin square. Whatever be the trigonometry, the power is even means it is an even function. And whenever it is even function, We remember the formula 2 times 0 to a f of x dx. In this question, instead of x, theta is given. So, all the formula that I use for x, I will use for theta now. So, rewrite this integral as 2 times 0 to pi by 2 sine square theta d theta. Can I integrate sine square theta? No. So, in trigonometry, sine will become minus cos, cos will become sine in integration. Sine square or cos square are coming. Learn to rewrite using the trigonometry formula. So, sine square theta is nothing but 1 minus cos 2 theta by 2 d theta. This 2, if I bring it out, 2 and 2 will get cancel. Let me integrate. 1 constant will become into x if it is dx. Now it is d theta. So 1 will become 1 into theta minus cos will become sine. So cos 2 theta means sine 2 theta, and whenever 2 theta comes, divided by 2. 3 theta means by 3. 4 theta means by 3. Remember, between the limits 0 to pi by 2. I equals theta becomes pi by 2 minus sine 2 into pi by 2 by 2. Lower limit is 0. Sine 0 is also 0. So my answer is simply 0. This 2 and 2 cancels. Sine pi is also 0. So this also becomes 0. I am just left with pi by 2, and that is the answer. Third question, I equals integral minus 1 to 1 log 2 minus x by 2 plus x dx. Now this is not just x cube or sine cos like that. So I have to check whether this is odd or even function. So treat the given question as f of x. And I want to check what is f of minus x. So wherever x comes, let me put minus x. 2 minus of minus x by 2 plus minus x. That is log of 2 plus x by 2 minus x. See, this is 2 minus x by 2 plus x, and this is 2 plus x by 2 minus x. And you remember, when they are reciprocals, log 1 by x is nothing but minus log x. So when I want to write the reciprocal, put what symbol? Minus. Minus log 2 minus x by 2 plus x. So this is minus. This full thing I call f of x. I started with f of minus x and I ended with minus f of x, implies f of x is an odd function, and whenever it is odd, we say I equals 0. So minus 1 to 1 log 2 minus x by 2 plus x dx is equal to 0. What formula do we use? Integral minus a to a f of x dx equal to 0 if f of x is odd. So whenever we get an odd function, minus a to plus a integral reduces to 0. Here I have declared it is odd function. So in this question, we use this famous idea, log 1 by x means, that is whenever I want to write reciprocal, minus log x. So f of minus x is becoming minus f of x, declaring that f of x is an odd function, and so the answer is 0.